All right, so let's wrap up the eye right quick in vision. The pathway for vision, the way our vision works its way through the brain is like this: the detection and transduction of light, as well as image information, involves the visual areas of the brain, both for conscious awareness and interpretation. In other words, we see it and then we figure out what it is. The structures found within the visual pathway, first of all, you have what is referred to as our visual field. Um, this is what each eye sees with that eye alone. With both eyes open, the field of vision is divided into a right and left field of vision, with what is referred to as the focal point being found in the center. Here is our field of view. If you'll notice, the right eye sees everything from here all the way over to here. The left eye sees everything from here over to here. And then both eyes see what is found right here in the middle. That is why human beings have what is referred to as binocular vision. Other animals, those animals that you see that have their eyes more positioned over here to the sides, like this, may not even have their focal point, may not even be uh, an overlap, so they do not have that binocular vision. Binocular vision gives you very good depth perception. You can tell how far away something is or how near it is to you, and that can be very beneficial. The retina of each eye detects visual stimuli from portions of the right and left visual fields. Some axons carry visual stimuli across the eye, or excuse me, they cross at the optic chiasma. All stimuli from the right visual field are processed by the left hemisphere of the brain and vice versa. Go back to the picture. Here you see the signals in red coming over here to this side of the brain, signals in blue coming over to this side of the brain. The optic chiasma is a cross-shaped bundle of axons of left and right optic nerves within the skull, just inferior to the hypothalamus. When you did the brain, I'm sure you looked at the optic chiasma of the brain, and that shows where those optic nerves from the left and right cross paths going to the opposite hemisphere of the brain. And again, here is a expanded view of, this is what we see with this part of the retina over here. This is what we see with this part of the retina over here. And you're seeing cross fields. The optic tracts are formed by the axons exiting the optic chiasma. Stimuli from the left visual fields travels in the right optic tract and vice versa. The lateral geniculate nucleus is a region of the hypothalamus, of the thalamus, where the majority of the axons in the optic tracts terminate. Optic radiations spread out deep to the temporal and parietal lobes once they've reached the primary visual cortex, which is found in the optical lobe. Each half of the visual field is then represented entirely in the opposite half of the cortex. So again, things that you're seeing on your right are processed on the left. The individual is now consciously aware of the visual stimuli with basic analysis of shape, color, movement, and location. Integration with the association areas of the other brain regions assists in fine-tuning the image. Again, we become consciously aware of something. It's big, it's sort of rectangular shape, it's red and silver, it's moving toward me, and its location. Then the association areas tell me, oh, that's a semi truck coming this way. Don't pull out from the stop sign just yet. Again, there is the visual pathway, again showing where in the brain signals go and then where they come from. Consensual pupillary response, constriction of both pupils in response to light entering the left or right pupil only. Some of the axons for this process terminate in midbrain, where they communicate with the oculomotor nerve that innervates the pupillary muscle in both eyes. When light is detected in one eye, The pupil is constricted in both eyes reflexively to prevent damage to the retina, optic nerve, and brainstem. Also, your eyes will exhibit what is referred to as sympathetic movement. When your right eye moves, your left eye moves in concert with it. Very few people are able to move one eye while the other one sits perfectly still. Stereoscopic vision or depth perception is perception of distance objects or perception of distance that an object is from the eye. To have good depth perception, eyes must face anteriorly. Much of the visual field for one eye must overlap the other eye, which is known as binocular vision. And the brain compares overlapping images to determine the distance an object is from the eye. Images that are processed by the brain involve more than detection and conscious awareness. First of all, the retinal axons project a lateral geniculate nucleus and primary visual cortex where the image from the retina is mapped. Visual information then follows two pathways from the primary visual cortex. They will either follow the dorsal pathway, which leads to the parietal lobe, or they will follow the ventral pathway, which ends in the inferior region of the temporal lobe. The dorsal pathway gives us an interpretation of motion, whereas the ventral pathway processes colors and forms. There are many other regions of the brain that are associated with visual memory and behavioral decision making, again, based on certain visual clues. So the big picture, again, of vision: lateral, the left lateral view, the right lateral field. Remember, things on the right are processed in the left, things on the left are processed in the right. Motion is up here. Interpretation for speed and distance is down here. And that is the big picture of vision. Rods and cones. Rods for black and white vision, cones for color vision. All right. We're going to stop there, and we will pick up with anatomy of the ear at a later time.